Today, our talk we're going to have talk about moving the needle, some of the step changes that we can accomplish, that continuous improvement, and some conclusions. Today, moving the needle. Operational improvements come in two ways. Really, they are the big step changes. They're the biggest impact, but there's limited opportunities for these. These come from strategic mine planning, changes in philosophy, that outside the box thinking. Not the what color is the sky in your world outside the box, but outside of our comfort zone. We have to look at those ways for us to improve. The other way, once you've exhausted those step changes, is that continuous improvement, that fine-tuning of proven processes. Step changes largely come out of strategic mine planning. The things that we include in strategic mine planning is looking at your equipment fleet, looking at your pushback sequence optimization. You look at what is the best sequence for you to mine the different pushbacks to get the maximum value out of this deposit. Look at our cutoff grade. Cutoff grade can vary through the life of the project. It doesn't need to be fixed. It is something that we need to look at to make sure that we take into account all the value that we can get out of that. Your ore destinations. There's lots of different ways that you can source your ore. Now, it doesn't mean that it all has to go straight to the mill. You may put it on the stockpile, and you may go to a heap leach. Whatever is going to get you the most value, that's the order that you need to look at. Looking at your grade constraints. You may have 3 different pit areas. They may have all different properties. Is it best for you to take and mine one straight through, or is it better for you to set a limit and blend into that limit, blending the 3 mining areas together? That's something you need to look at because they can have significant impacts. Lastly, waste dump optimization. You look at that, and with it being a truck shovel mine, you are going to need to keep your trucks moving. So our waste development plan has an impact on how effective your truck fleet is. Step changes we're going to look at, some of the case studies we're going to see today. We're going to focus on pit phasing, haul optimization, optimizing production rates, and equipment updates and upgrades and how they can be effective. Look at our pit phasing. First example we're going to go to is Detour Gold. So Detour Gold, we had phase 1 was being mined. Phase 2 was a horseshoe around phase 1, and then develop our way to the west through the rest of the life of mine. One of the things we noticed 2019, 2020 in the mine plan, we had a dip in gold production and cash flow, and a lot of that stemmed from the fact that we had to feed the plant from the low-grade stockpile. What it was is this north end of the phase 2 is extremely high strip, and we couldn't get down to the good ore quickly enough. And so the other thing that was challenging with it is we needed to maintain an access on the south side out to the crusher. So we needed to look at ways for us to deliver better grade during those 2 years. So things we wanted to look at was reducing the size of phase 2, trying to reduce that stripping, moving along strike in the main part of the ore body, phase 3 into the west, and looking at ways for us to do that. One of the challenges, like I said, was maintaining that south access to the crusher. There's going to be a north access developed, but it wasn't going to be in place in time for us to be able to use it to be effective. So what did we do? Well, we trimmed out the north side of phase 2. We took that off there and we focused on the west end and the south side of phase 2, allowing us to get to ore quicker. We also put in a smaller phase 3A, which again is a low strip, which is giving us the better ore to be able to feed the plant while we offset the continued stripping on this north end. One of the other pieces we had to look at was this south portion is pretty narrow, so we ended up having to add some waste to the ultimate pit for us to be able to access the later phases by taking phase 2 the way that we are talking about. What did we accomplish? We were able to pull that gold release forward by doing that smaller phase 2 and focusing on the main part of the deposit and being able to delay some of that stripping. We smoothed the gold production and the cash flow. As you can see here, the previous plan, the 2017 life of mine plan, had this dip in 19 and 20 and a spike in 21 and 22. We were able to smooth that off with a new plan, smooth that out, and improve that cash flow. That additional waste that we had to add in really didn't affect the NPV because it was offset by the fact of us being able to pull this additional production earlier into the schedule. That allowed better planning for the operation, for capital and for expenditures because of that smoother profile. Being truck shovel mines, trucks are the key thing for managing your costs. So halt optimization is a big thing. This next example is a large copper mine. During a period of low copper prices, identified that we needed to cut our operating costs by 20 to 25 cents a ton to make sure that we could weather the storm, get through that low period in the cycle, and get back onto the other side for the rest of the life of mine. Haulage was identified as a key opportunity for us. One of the things, we were just finishing off this phase, and in the northeast corner of the pit, it was identified that there was an access that was being left to access later phases, with a little bit of ore left in the floor. Capacity for backfill in the pit wasn't fully utilized in later pits because just it was shorter haul distance for us to go to other locations. What did we do? Well, we came up with a plan that we could use a temporary access to mine out the last couple of benches of ore in this northeast corner. It allowed us to do that, to open up some backfill space. It allowed us the capacity for about 90 million tons of backfill into that corner, but affected the access for the later phases. Because of us moving that dump out, we lost some of that distance. We were able to push out this ramp into that next phase, and we were able to fit it in so that we were able to not affect the bottom and still get the pit bottom that we were looking for, and not have that. What did that early backfill allow us? What that did was 9-month period of shorter hauls. We were looking for 20 to 25 cents for 6 to 12 months. We got 9 months of shorter hauls. We had a 19-minute reduction in the haul cycle. What that allowed us to do is take our bigger, more efficient fleet and run that, and not have to run the older high-cost fleet. So we were able to park that fleet. It increased the life of mine backfill, and it reduced the life of mine haul distance. All of those are positive things. And the impact was 45 cents a ton mined for 9 months. What that equated to was 40 million tons or $40 million of savings over that single year period. Next thing, rehandle's bad, right? Not always. We need to look at what's the right amount of buffer around a pit for future expansion. Sometimes there's value in rehandle, even when it's covering known reserves. This example is Sierra Gorda in Chile. This is the pit that was defined. It's about a 25-year pit in the feasibility study. The blue dumps that you see were part of that feasibility study. What was looked at was there was a 500-meter buffer around the pit that was identified that it was near economic, and with a little bit higher copper price, it would have been definitely something that would have been included in the mine life. So didn't want to bury that. So we set a 500-meter buffer around the pit to make sure that we didn't bury the reserves in the feasibility study. When we looked at it, though, the problem that comes in is that 25 years of mine life, you're hauling everything 500 meters farther because of that buffer. We wanted to look at what the impact was. There's actually another small little pit underneath this dump here. These orange dumps, we said, okay, let's narrow that buffer down to 100 meters. That's good for geotechnical. Let's see what we can fit in there. Turns out we could fit 1 billion tons of waste in that buffer. All of it was going to be over known reserves. So we were looking at it to see what that impact was. That 25 years of hauling that extra 500 meters was something that we wanted to try and avoid. With that billion tons happened in the first 7 years of the mine life. That allows us to save over $40 million in haulage savings by dumping there. So that's all in the first 7 years. Said, well, if you did expand out, what would be the impact? We looked at that. We did a discounted cash flow on that. And the NPV actually was improved by $4 million by short dumping and rehandling. There was enough value in those $40 million up front to push that out to the 25 years and rehandle that billion tons of material to have those savings in the first 7 years. And it also helps the payback and the returns on that investment. This is a big impact. This is one of those ways that you can look at it, that rehandle isn't always a bad thing. Next, look to optimize your production rates. It's important to plan your production rates to make sure that they match the mill and to the mine, and the highest impact on the operating costs or the revenue. An example is when the mine cannot deliver enough ore at the planned cutoff grade. You need to look at your cutoff. If processing has the highest impact on your cost, anything that you can put in there and keep going is going to be a benefit. If you're not filling the crusher, it's the same cost for you to run that mill. If you lower your cutoff grade, you're getting a little bit more out the back end. That's improving your revenue. So in those cases, it's better to keep the crusher full. So looking at a lower cutoff grade may provide you with better returns. Next thing to look at is if the mining has the highest impact, maybe starving the mill is the right thing for you to do. That's the analysis that you need to look at. On the flip side, here's one where you raise the cutoff grade. Look at that high grading in the front end. In this case, all these graphs, the green is the original, the purple is the high grade option. See how much grade we've pulled forward in there, but there's a cost to that. The total material mined in those first periods has gone way up from the original case. But there's considerable value in this. The value of that high grading strategy allowed for $30 million increase in the NPV of the project. The rate of return increased by 3%, and the payback period was reduced by a year. For a project that's coming into production, that payback period is key to when they're going to pay back that capital investment. So it being done a year earlier is a significant impact. This is a place where you look at that high grading option, and it has potential to help you out. Equipment upgrades. We all do it as you go through. You're aging and you're mixing your fleets. You start off with a smaller truck fleet, smaller shovels, and as trucks get bigger and faster, you add those new trucks to your fleet. The thing you need to remember is your truck fleet is only as fast as the slowest truck. Slower trucks cause bunching, additional queue time. When you go through that, it's really difficult to set up effectively for haul trucks to pass. So even if they can, those slower trucks are still slowing down the bigger trucks until they get to that area. So it's important to match your fleets. And the other thing to remember is smaller shovels with big trucks means reduced truck productivity. Your trucks aren't productive when they're sitting under the shovel. The trucks are only productive when they're moving. So the more time they sit under the shovel getting loaded, the less productive those trucks are. Best way to look at this, send your largest truck fleet to your largest shovels wherever possible. This minimizes your impact. Segregate your fleets if you can. Keep your slower trucks and your faster trucks apart, because that's going to eliminate that bunching and the additional queue time that comes with it. Moving on to the continuous improvement. Things with the continuous improvement, you need to know where you are. You need to look at your overall site performance. Look at managing your asset. Use your data. That's the thing that we need to look at. To know where you are, you can't really reliably improve your production and your performance if you don't know where you are. If you don't know what your past performance is, you can't tell what you're doing if it's better or worse. So you need to be able to manage that data and know where you are to be able to look at that performance improvement. Another key, benchmarking. You need to know where you are relative to your peers. Relative to your peers, you need to know, you may think you're top of the heap. Sometimes somebody does something a little bit better than you do. This is a way for you to identify some low-hanging fruit for your improvement plan, ideas that you can implement quickly and be able to have that impact. AMC has a large database of validated performance and cost data to benchmark your operations versus your peers. This is something that we can do. We can do a performance diagnostics review with you and get you to know where you are relative to your peers so you can have that information. For us, we can do performance diagnostics. We can collect the data either through a site visit or desktop, collect that data, standardize that data so that we can review it against that validated data that we have from your peers to be able to let you know where you are. We analyze that data and provide short-term and mid-term interval goals and areas for improvement and work with you to develop that plan on how you can improve. An example of this, an open pit site started off the year, they were behind. They were looking for ways, they wanted to make sure that they were going to be able to achieve their end of year target for material movement. So AMC came in and did a bottleneck review as well as areas for potential improvement. It became very obvious that drilling was the bottleneck. The load and haul segments, they had the capacity there, but the drill just wasn't keeping up. So looked at those drills and said, okay, what is it that's going on? Is there places for us to improve? Plotted the use of availability and availability relative to the peers. So all these other spots are all the other mines around. Year to date, you can see where they are. Part of that was largely impacted due to some significant weather events that slowed down the production at the start of the year. And we've got this month, last year, and the best performance. You can see that this site is operating very well. They're in the top quartile of their peers. There's not a lot of room for them to make significant improvements to their drill fleet. They can make improvements, but it's going to be very challenging because they're going to be on the leading edge doing those improvements. They used this information. This was the information that they were looking for. They found that making those improvements to their capacity with their fleet, their existing fleet, was going to be challenging. So they used that information to go out and find additional capacity. They didn't have enough time to purchase drill fleet, so they got contractors to come in to help them to do that. When they did that, they brought that in, they were able to achieve their target for the end of the year because they had that information out front. They knew that it was going to be a hard stretch for them to improve their capacity with their existing fleet, so it gave them the information to make those decisions. So that's one of the key things you get out of benchmarking. Overall site performance. One of the biggest ones is a mine-to-mill program. This example is from a copper mine. The initial goal was just to provide consistent primary crusher feed by eliminating oversize. So first thing did is, okay, let's improve the fragmentation by increasing the powder factor. This resulted in a 3% increase in blasting cost. Of course, all the mining guys are like, oh my God, I'm increasing my cost. But when you look at it as the overall site, you look at it, it improved the primary crusher throughput by a 1% increase in production. Doesn't sound like a lot, but what that equates to, it was about a $4 million savings per year by that small increase in the production in the mill. These are the things, is sometimes there's some costs that we need to take advantage of in the mine, increase those costs to make the mill more productive. That keeps the whole site more productive and performing better. We ended up with some additional benefits when we looked at this. You know, we looked at it and said, look, the shovel productivity increased by about 15%. This was because the fragmentation was that much better. The shovels weren't working in the face. They were faster through the muck pile. Truck cycle improved by 10 seconds per load. Again, Not a huge increase on its own, but you think about that, we were able to park an existing high-cost fleet because we were able to trim the amount of hours that we needed, just because those trucks were moving, they were productive, they were not sitting under the shovel getting loaded. It also was a reduction in shovel bucket maintenance. Overall, we were seeing an improvement of about $5 million a year because of the improvement to the fragmentation. That 3% increase in blasting costs increased, but it also gave us a total overall savings of more than $5 million a year. Manage your assets. In this next case, we're looking at truck replacement schedule. When you look at it, the red curve is the trucks that were required. As you can see, the spike is late in the mine life, and it tapers off quickly after that. The standard plan is to follow that required, get the trucks that you needed, but then do your replacements. What happened with this case is that this spike coincided with the end of life for the early truck fleet. So you're buying new trucks as well as replacing old trucks all at the same time. And you ended up with needing about 50 overall truck purchases. What was looked at was a early replacement plan. This original plan, you ended up buying a lot of trucks late in the life, and they were at about half life when the mine was complete. So you had a lot of assets that weren't fully utilized. Using this early replacement plan, what we were able to do is we were able to reduce the number of overall trucks by 5 by reducing the number of purchases. But what we did is by doing those purchases a little bit earlier, we were able to park some of the aging fleet and save them to be able to use during the spike and then retire them right after it. What we ended up with was the fleet was about 80% of the fleet was over 70,000 hours at the end of the mine life, which basically we've utilized that fleet to its fullest capacity, which is a great plus. You're not looking for salvage value out of it, because everybody knows when you're selling used equipment, a half-life doesn't mean you get half the value. It's something considerably less than this. So this is maximizes your capital. Yes, it does pull a little bit, the purchase a little bit ahead, but the NPV for this case was still superior to delaying those purchases. Next one, use your data. We all have a lot of data. Most mines have a fleet management system and a drill navigation system, and you get a lot of information there right off the bat. But do you use all of that? Set up some standard reports. Not talking the canned reports that you get out of your fleet management system. Everybody uses those, but those don't set you up for your site specifically. There's information that operational leadership needs to have, and those should be in those standard reports. Set those reports up, whether that's for drilling from the navigation system or for load and haul from the fleet management system. Those are all pieces that you can use, and those standard reports give everybody the information right up front. Next one, driver trees and dashboards. Dashboards. Nobody realizes they are not doing as well as they could if they don't know. So what you look at with the dashboards, take advantage of that. Give the operators, give the foremen, give them that information. Show them how they're performing relative to what your target is, and show them where the gap is. And seek out them giving you that input. They're out there every day. They're seeing different things than you are. If they know that they need to improve, that gives them that opportunity to do so. Use those dashboards to get that information out there. Driver trees. We all may know that shovel production is up or down, but it's the things that are in there that we need to look at. And why is that shovel production down? Is it the hours? Is the availability down? Are we not utilizing it? Do we have enough trucks there? If you use a driver tree, you put all of this report together in a quick and visible way, so somebody can look at it and say, shovel production's down. Okay, it's related to availability, or it's availability of trucks for that shovel. it quickly allows you to set your focuses and be able to identify the areas where you can improve. Next one, use that data for correlations. Some of the things you look at, the first one, we've all done it. You have a bad blast. So you say, okay, we need to make some changes to this. Let's adjust the powder factor. And you blast it and you go out and you look at it and you say, yeah, it looks like the fragmentation's a little bit better, but it's really difficult to quantify how much better that is. So easy way, shovel dig rate versus powder factor. You can then clearly see if the dig rate goes up by increasing the powder factor, then it allows you to quantify that. It allows you to put those dollars in the right place and allows you to justify that increased blasting cost. Next one, load time versus truck wait time. You know, you need to look at how your truck wait time is versus your load time. You look at your load time and you go and look at it. There's a couple pieces that you get out of this. First is your trucks. If you have your wait time is getting close to your load time, you can then say, hey, I've got too many trucks on this haul, or it's time for us to park a truck because waiting trucks don't add any value. So you need to look at that. The other thing is your load time versus shovel wait time. You know, are those shovel operators, and it's human nature. We go through, and if you're under the gun to make sure that your production is up, I can guarantee your shovel swing time is going to be at the top of your game. If you are waiting for trucks and everything like that, you're not going to be as energetic to get there because you know you're just going to wait for the next one to come. So there's not that pressure. You need to manage those things. Looking at those correlations helps you to be able to do those. Last one, speed maps. This one is an interesting thing that you take out a fleet management system. You get all of this information. What you could do is take your instantaneous speeds and plot them. And so what we did at Detour Gold, we looked at that and we were looking at it. And we had our predicted cycle times were quite a bit lower than what we were actually achieving. We're trying to figure out where it was. So we said, okay, let's plot up a speed map and let's look at the cycle. What our goal was to see if we had, really missed our truck speeds. When we did that, we were able to see that it's okay. You come off the shovel and then you speed up and you're good across the flats, and then you slow down as you're at grade coming out of the pit, and then you speed up on this flat section. Oh, what happens out here? This is a long flat stretch. The truck should be flying along there. What's going on with that? We were able to identify that. We still couldn't see it, so we went out and got on with a haul truck driver and went out there, and you go down there and you're like, why are you slowing down here? And he's like, well, it's hard to see in a pickup, but there's a wave in the road here and it makes the truck bounce and you feel a little less in control, so you slow down. So we found this to be a great tool for us to be able to identify areas for road improvements. We took this and said, oh, so went in, fixed that up, all of a sudden the trucks are flying through there. We then use this as a tool for us to identify areas for road improvements. And it wasn't done all immediately. It was identify this area and then improve it. And then gradually we worked our way through. Over about a year period, we were able to improve our productivities and improve up to where we thought we should be. It was about a 10% overall speed increase on our health cycles just by us being able to identify areas of the roads that needed additional improvements. So speed maps, the data's all there. You just got to plot it out, and it gives you a great indication of where there's problems on the road or problems with your haul that you can fix up. Conclusions, places to look for operational improvements. Really, there's the step changes, that changes in philosophy, and the strategic mine planning. Those are things that are going to have those big changes. There's a few of them, but they're not as widely available as the continuous improvements that you have relative to yourself and your peers. That fine-tuning, that tweaking of the proven processes. All of these are places where you can look for that. AMC can help you out with all of these aspects, but those are some of the places where you can look for those improvements. And thank you very much. And are there any questions?